Well, so we pass on the system to have the model, and later we try to have some concept to have the simulation. So let us have the system models and simulation. Well, previously we emphasized the nature of simulation. We have a system. We need to have the model, and then we have a simulation. So we emphasize the next one, systems, models, and simulation. Well, system, here we have the some further description. A system is a collection of some entities. For example, machines. I think it's easy. All right. Even you have the whole system, but sometimes you will focus on part of the system. And then that part of the system is the real system you focus. And right now, we focus on that system you are interested in. And for that system, we will define stats because you need to measure the performance. So you need to have the stat of the system. To have the system, normally we can have the discrete system or continuous system. And actually, you may have the mixture of both, discrete and continuous. But later we will have the discussion for the discrete event system first. All right. So in fact, we have the system, and you may have a discrete or continuous, but later we will focus on this discrete event system. Well, discrete continuous, I think you can check the definition by checking countable or not. If we have a state countable, and then we will have a discrete events, discrete system, or otherwise you will have a continuous system. At this moment, maybe I just mentioned countable or not. You need to check that one so that you know discrete or continuous. If we have the concept of countable, and then we can define discrete system. If it's discrete system, then we have the countable number of variable, or otherwise uncountable stats, and then we will have the continuous system. Well, I mentioned this for your reference. If you want to check the definition of discrete or continuous system, you can use the concept of countable. Well, up to now, I've mentioned a system. And for the system, actually, we will have possibly we will have the model. Well, first of all, if you don't want to have the model, you just want to have the actual system, you can run. Or maybe you can do the experiment, and then you can have the result through the experiment. But otherwise, for the experiment, we have the model, right? We have the model, and once we have the model, please that we have the mathematical approach. And mathematical approach, actually, we can have the analytical solution, or we have a simulation. So previously, we have the two branches. Even for the two branches, simulation, we still need to have some mathematical relationship. If you don't want to follow mathematical model, then we have the physical model. As for physical model, in fact, we have the others, but we stop here. And likewise, we stop here. We just emphasize if we have a simulation or analytical solution, we will rely on a model, mathematical model, and finally we will have the analytical solution or simulation to have the solution. Well, that's it. This is a way to study a system if we want to measure the performance for the system you focus. Well, For the system, we know we can have a discrete or continuous, right? And in fact, we can have a static or dynamic. Static system or dynamic system. If the state, it won't change as time goes, then it's a static system. Otherwise, we have a dynamic system. And for this one, about some event, you can find it for sure, or we have uncertainty. If we can find it for sure, and then it is the deterministic. And if we have some uncertainty, then we have the stochastic system. Well, actually, we can have static or dynamic, deterministic or stochastic, continuous or discrete. And finally, we want to have a subsystem, this one, discrete. All right, so discrete, not static, actually is dynamic. Discrete, and then events, actually we will have a stochastic simulation. So we choose discrete, stochastic, and dynamic so that we have the discrete event simulation. All right, so later we will have a discrete event simulation, but we don't focus on continuous system because we want to start from a simple one.